Hello, this is Mr. Doro. Today we're going to be talking about concentration of solutions, and by the end of this little tutorial you should be able to perform calculations to determine those concentrations. We need to know what concentration is. The book definition of concentration is the measure of the amount of solute in a given amount of solvent or solution. We can think of it two ways. Qualitatively, which means we're not really measuring it, we're just saying whether something is concentrated or dilute. You can think of this as the frozen orange juice. That would be a concentrated. We needed to dilute it down by adding water to it. Quantitatively is what we're going to be doing in here. We'll be doing mass percent, but mostly we'll be doing molarity. There's also something called molality that we can use too. If you look at both of these solutions, they have the same solute and they have the same solvent, but they do not have the same concentration. This one over here on this side has the same amount of solute, but it has less solvent in it, so that means it's going to be more concentrated. This one has more solvent in it, and so this is going to be less concentrated or more dilute. Now this is just like if you were to make lemonade. If you were to make lemonade and you found out you tasted it and it wasn't strong enough, maybe like this one over here, then you have to add more solute to it. And so you put more of the lemonade mix in it. If you taste the lemonade and it was too strong, then maybe it's like this one over here, then you have to add more water to it to dilute it down some. Here's another example of making a solution more concentrated. We started out with some dilute copper sulfate solution. It doesn't have many molecules in it. We add more copper sulfate, and so as we get more copper sulfate, it starts to get more and more concentrated, and when we add enough to where it can't hold any more, then it ends up being a saturated solution. And if we want to dilute this down more, then we would, instead of adding more solute, we would add more solvent or more of the water to dilute it down. So when we do concentration in our class, we're generally going to be using molarity. Molarity's formula is written right here, and you need to write it down in your notes. Molarity is the amount of solute over the volume of the solution. And these are the symbols for it. Capital M is molarity. Moles is the amount of solute, and liters is what we measure the solution in. And so molarity is moles per liter. Now sometimes molarity will be written like this, and this is called 0.500 molar. That's the molarity, and that means 0.500 moles for every 1 liter of solution. It's important that you know that we can break it down into this. Sometimes molarity problems can be pretty simple. In this case, you're given the number of moles of whatever the salt was, and it says it's dissolved in 500 milliliters of solution. Remember, molarity is, when it wants to find molarity, that's moles per liter. This was milliliters though, and so we're going to have to change that over to liters, and we can do that. This is molarity, capital M, is moles per liter, 0.720 moles over, and in liters this is going to move, the decimal is going to move over 3 places because you're going to divide by 1,000, and so this is 0.500. Those are significant because of that decimal. Liters, and when you solve for that, you end up getting 1.44 moles per liter, or 1.44 molar. That's what the big M stands for, molar, which is moles per liter. Now, all molarity problems are not as easy as that last one though, so sometimes you're going to have to use molarity in action lines. So in your notes, you really want to write this down, and put a star next to this one right here. And so I'm going to put a star next to that one. This is never, never start an action line with molarity. If you're given molarity in the problem, don't start the action line with molarity. Molarity should be used to convert between moles and liters. Now, this is important here also. It says if you're solving for molarity, start with something that you can change to moles on the top and something you can change to liters on the bottom, because we want to end up with moles per liter, which is molarity. So if you're asked to find molarity, in any case, you want to start your action line with something that can be changed to moles, like maybe it is moles already, or maybe it's grams. And then on the bottom, we want to start with something that we can change to liters. Maybe it is liters already, or maybe it's milliliters. That's what we want to start with each time. So here's an example of a problem that you're going to have to use an action line. Well, at least it works best if you use an action line. It's asking for molarity in this case. When we're asked to find molarity, remember, we need to start our action line with something on top that we can change to moles. Something on bottom we can change to liters. We're given 250 milliliters of solution and 29.0 grams of NaCl, and so the thing that we can change to moles is the grams right here. So we're going to start this out with 29.0 grams NaCl. Now this is a little different than we've done before. On the bottom, we're going to put something that we can change to liters, which is 250 milliliters. Now, we have to pick which one are we going to change over first. Are we going to change over the grams to moles or the milliliters to liters? It really doesn't matter. It's your choice. I'm going to go ahead and change the grams over to moles. So down here, I'm going to put grams of NaCl, moles of NaCl. And for every 1 mole, I have 58.44 grams of NaCl. That's from the periodic table, from the molar mass. Grams is gone bye-bye. I'm left now on top with moles. If I were to stop right now, I would have moles of NaCl over milliliters. I don't want moles over milliliters, so this is kind of a weird thing. This is different than we've done before, but watch what's going to happen. I'm going to start another action line in this milliliters right here. I need to get liters on the bottom, so to cancel this out, it's okay that I'm skipping way over here. That's okay. I just need to get milliliters on top so it can cancel out. So I'm going to put milliliters on top, and I'm going to put liters on bottom. And if you remember, I think it's always easiest to put a 1 in the bigger of the two. Liters is bigger, so I put a 1 there, 10 to the third right here. Milliliters cancels out, and look what I have left over. Moles on top, liters on the bottom, and then I can plug it in and solve for it. And multiply everything on top, divide by everything on bottom, and you should end up getting 1.98 moles per liter, or 1.98 molar. Capital M means the same thing, and that's how you do an action line solving for molarity. Now this is another action line problem, but this one doesn't want to find molarity. This one wants you to find grams of NaCl. It gives you a volume right here, because you know that because of the milliliters, and it gives you molar, 6.00 molar. Now here's what I would do right away. When I'm given this, I know I'm going to have to put it in the action line. I would cross this out and put moles per liter. That means 6.00 moles for every 1 liter. And so that's going to help me out when I do my action line. Remember, we never start an action line with molarity. So there's only one other thing left over in here that we could start our action line with, and that's this 50 milliliters. We are not going to start it with this. This is going to be in the action line in a conversion factor. So I'm going to start out with 50 milliliters, 50.0 milliliters. Now we know in our action line what's got to go down here is we copy down milliliters. If we're given milliliters, we got to change it over to liters, because we got to get to this point where we can change over using moles and liters. So I'm going to change this to liters. This is 1 liter, 10 to the third milliliters. Milliliters cancels out, so I keep on going. On the bottom down here, I copy down again, liters. Now this is where I can change over from liters to moles using the molarity that was given to me. I'm going to put moles on top, not a capital M, but moles. 6.00, the number goes with the mole part. Whether the mole is on bottom or on top, it doesn't matter. The number goes with the moles. It does matter in this case where it is, but in some cases you'll get the moles on the bottom. This is for 1 liter. That right there means 6.00 molar, or 6.00 moles per liter. But I'm not done, because this wants me to get to grams. And so I got to keep on going. For every 1 mole, it is, and this is NaCl, so this is 58.44 from the periodic table, grams. Look, moles cancel out, liters cancel out, milliliters cancel out. I'm left over with grams, and the answer that I end up getting when I calculate this all out, I start multiply everything on top, divide by everything on bottom, and I get 17.5 grams of NaCl. And I could have plugged in the NaCl each time here, at least when I got to this point, 6.00 moles of NaCl, and then moles of NaCl, grams of NaCl2. And our last type of problem that we're going to go through here, this one wants to know what is the volume in milliliters. That's kind of important right there, in milliliters. This gives us a molarity, 2.35 molar. I'm going to cross that out and put moles per liter, just so I can remember that goes in my action line. And it also gives us 31.6 grams of calcium chloride. Calcium chloride is CaCl2 when we check the charges on that. So we start out with, well, what do we start out with? We don't start out with the molarity. So the only thing we can start out with is 31.6 grams. 31.6 grams CaCl2. We want to get to a point where we can use this to switch over between moles and liters. And so that's what we're going to work on right now. We keep on going right here. Grams of CaCl2 to moles of CaCl2. And this is 1 mole. And this is 110.98 grams from the periodic table. And so grams are going to cancel out. Moles of CaCl2 are going to go down here. Now this is the point where I can switch over from moles to liters using, right here, my molarity. It's okay that moles is on the bottom. That's not a problem. We're just switching between moles and liters. So I'm going to go to 1 liter, and the 2.35 goes with the moles down on the bottom. Now moles cancel out, and I want to get to milliliters because that's what the problem asked me to find. And so I put liters here and milliliters here. For every 1 liter, it's 10 to the 3rd milliliters. And so then I plug this in, my calculator, multiply everything on top, divide by everything on bottom. And I got in 3 sig figs 121 milliliters, or 1.21 times 10 to the 2nd milliliters. And so that is my volume in milliliters. Always got to look what you're given and what you're asked to find and work your way through it. Okay, so I got 3 problems that I want you to try. These are all action line problems. I'm going to give you a couple hints right now. First of all, this first one wants you to find molarity. Remember that you want to end up with moles over liters. So you want something that you can change to moles on top over something that you can change to liters, unless it already is liters on the bottom, and I'll give you the answer to that in just a second. The second one right here wants to know how many moles, and it gives you a concentration in molarity, that's moles per liter right here, and it gives you a volume. Remember, we never start our action line with moles per liter. That's just what we switch over from moles to liters. And same thing with letter C here. What volume? And it gives you moles per liter right here. It gives you grams. Never start your action line with this, so you know what you need to start your action line with. I'm going to give you the answers here, and then you can go at it. So here are the answers on that. 0.282 molar Ki. 0.0750 moles on letter B, and I've also put it in scientific notation. 0.834 liters on letter C, and also in scientific notation. Really, you got to try these out. Go back and check out the examples if you need to, but you really got to know how to do these, and if you can't get it, just do the best you can, and we'll figure out where you got stuck, and we'll work it out. All right, have a great night.